feel very stressed. You will record, I will very stressed. Huh? Anyone doing recommended system for the assignment?
image processing 可以做了，detect 名字，
detect 名字
detect 名字就好了。但是有什么 feature 要加，然后它是你的脸，然后它懂你是机上 ，OK， 然后它是 Jackson， 就可以了。还是有什么要求
？Maybe 你可以加更多的，比如，
比如这明星脸啊，放茶叶的地方在放加个照片，在电话里面，然后 detect 茶叶的脸。
首先你要看到你的 objective 什么，你要 detect trace，你要 detect trace 来做什么 ？verification 是什么？你的 objective 你要不确，你要做什么？好像 previous thing 是要做 object detection。OK，object detection 是什么？它的 clear idea 是我要做 object detection，然后我要看它有没有访问的。说对了，它不只是说 object detection， 它是detect 那个 speculate， detect 那个时候，说你要怎样去 check 它是不是访问的呢？说这个就要 involve 到你要 measure 那个 coordinate 啊，它有没有访问的？所以你 measure 访问的它就是coordinate 变了，我们就有这样的访问的。像你的这样给 object detection。Face detection 现在要 then 说完，说你要你要 verification test， 你要 process 怎样 detect 你要 verification， 你不能 stop 在 face speculation，face speculation 很简单嘛，就是你会你知道了，不然你要。Okay, everyone. So, good evening. I know everyone is tired. I also very tired. How about until 8? Oh, you not all you right?
House modeling and blockchain.
Oh, elective?
Yeah.
I look at your timetable and opening lah. Yeah. Look at your timetable.
Regret.
Okay, so download this folder, recommended system. So inside this recommended system, you will have 3 different Python files. Part 1, 2, 3, as well as 3 data sets. Okay, depends on movie reviews, IT, as well as I don't know what thing of the data set. So you will see probably like this. You will have this 3 practical files, so this one will go, and then 3 data sets. Yeah, now the folder. Okay, as usual, allow me to explain what is recommended system and how many types of recommended system that you would like to usually learn from this practical. What is recommended system? Sophie. My question, what is recommended system?
The system recommends something.
Okay, yeah, a system to recommend product based on preference. What is the example? Yes, Sophie. Lazada. Okay, so we have a different type of recommended system available in the market. The most common one that you probably see is the simple recommended system. Simple recommended system is where we collect like the movie review, right? The movie. So we collect the information, let's say the word count, or maybe we collect the information about the rating. Okay, then we'll just probably do a sorting about each of these features. Let's say we sort the rating Zuanzi. Okay, rating is very high. Then we do a sorting. Okay, maybe we have a choice solving. 26 choices from the highest to lowest. So this is so-called simple recommender system. We don't have, you do not need to have a much of special skill to build this simple recommender system. As long as we have this information, then we do a sorting from the highest to the lowest to highest. Okay. So simple recommender system is shown in the practical one. I don't think I will cover this practical one because you just probably do a sorting. You can perform in the Excel also. So then we have a second type of recommender system. It's called content based. So since your group is doing recommender system, probably you have to find some information, right? So what is content based recommender system? You're doing recommender system, right? So you haven't decided. Oh, okay. So what is content based recommender system? It's based on the similar properties. It's based on the similar properties. Like today, you go to Shopee. Okay, you search Coca-Cola. Okay, so you scroll down the Shopee page, then you'll see one icon called you may also like. Okay, and then you'll see that if you promote all the product that's quite similar to Coca-Cola, for example, Sprite. You have a 7-Up, you have a Pepsi to the user. Why? Because similar? Yes, similar properties. So what is the properties of Coca-Cola? Carbonated, maybe price, maybe the color, maybe based on the function.
Diabetes
Bring you happiness. Diabetes. Okay. Maybe that is not a good problem. Yeah, we won't. Okay, we know that there is a properties, but we won't consider that. We will take a positive one, but a generous properties. Let's say we have these properties, so we try to go to the database and search the product that having similar properties. Price carbonate. The price range is about similar, so we will promote to the user. 7-Up carbonate drinks is about the same. We promote to the user. But what is the limitation using content-based recommender system? Do you think what is the limitations using content-based?
Sometimes the property is not same.
Sometimes the property not same. Then we don't promote. The main limitation for very good answer. Okay. The main limitation for content-based is the scope is limited. Assuming that you are managing one pizza shop, Domino pizza. Okay. So a user is ordering a pizza called Hawaiian chicken. Pizza. Okay. Based on this content data, what do you think this Domino will promote to this user? Let's say you have a user one. What type of product you probably so-called promote to the user one? Another type of pizza, right? Maybe BBQ type of pizza. Maybe black pepper. Hawaiian chicken. BBQ.
Cheese.
Cheese, okay. Cheese pizza. So you can notice that the product that I recommend to this user is all limited to pizza. Or if let's say now you have a new product that in the Domino called brownies. You have a ice cream. Huh? Then this new product cannot reach to the user. We have this problem. Okay, we have a new product, but that they are not pizza, but somehow, based on this content base, We just promote these three visas to this, but somehow these new products all are hidden. You cannot reach this user. So that's the main limitation for content based. Because why? Based on the similar properties.
Then relationship.
Huh?
Add-on relationship.
Add-on relationship. What kind of relationship?
Maybe like pizza cutter.
Pizza? Cutter. So you promote pizza cutter to your user. Okay, can also relationship. So we're going to solve this content based using another type of recommender system. But however, what is the advantage for the content based? It's easy to build. You just need the product's properties where you can easily obtain from Google, maybe from the manufacturer. You can get all the properties as your database. Then you just return it. Right? So we are going to solve this content based using another type of recommender system known as collaborative or filtering. Collaborative means that you need different users to collaborate, build this recommender system. Okay, so what is collaborative filtering? In order to build collaborative filtering, you need this table. You need this table called user item matrix. Okay, I repeat again. So why we need this collaborative to solve this content base? How to build this collaborative? You need this information. So what is user item base? It's referred to, let's say now, okay, we're talking about Domino. So we have a Hawaiian chicken, pizza. So we have a brownies. Okay, maybe the third one we have ice cream. We have three different products here. Now we have user, Jackson, Jai, Wison. Okay, so we have three different users. So Jackson bought pizza. Wow, he liked the pizza. He gave rating 5 out of 5. And also Jackson bought brownies. Wow, good taste. 5 out of 5. So Jai also eat pizza. He tried. But he never tried ice cream and brownies before. Okay. And then maybe Wison just tried brownies, cake and ice cream. Let's say we have this table. And this empty here is referred to that the product that never tasted by the user. So from this table, we are able to identify or to perform the clustering. We will assume that a person who likes pizza, okay, they will probably like brownies also, based on this first case. Can you see now? The first user, he likes pizza, he also likes brownies. Then we assume that Jackson likes pizza and likes brownies, and we can make an assumption whoever likes pizza, probably he or she will like brownies also. So now Jai bought pizza and he said, oh, 5, rating 5. Then since based on our previous assumption, we like pizza, like brownies also, so we will promote the brownies to Jai. So we are able to solve limited situation. We are not just promoting the pizza or pizza to the same user. Instead, we promote different products to different users based on this clustering. Is that clear? Okay. And also we can based on this. This is based on the item. This is called item base. We can also build a user base. We know that this user 3, he like brownies, and this user 1 also like brownies. We can say that user 1 and user 3 are quite similar. Jackson and Wison, they are quite similar. So since Jackson's like brownies and Wison like brownies, we can assume these two these two people, they are having similar behavior. They have the same common interest. And then since Wison bought ice cream, then we will promote ice cream to Jackson. So this is how collaborative filtering works, based on the rating. But what is the limitation for this? Is take a lot of time to collect it. How many of you bought the product, you consume, you will give a rating? You won't give rating, right? So if you don't give rating, then how Shopee collect all this data? Sales? Sales. Sales does not reflect whether you like or does not like this product. How they buy them? Again? Okay. So this is based on assumptions. Okay? So this means if you don't put a value, if you don't give a rating for product, then how does Shopee collect all this information? If you don't have this information, you cannot do corroborative filtering. So from now onwards, whenever you buy from the internet, whatever, give rating, so that this platform can build this corroborative filtering and enhance the customer satisfaction. Okay? So yeah, another problem for collaborative is you need a very big memory to store all the so-called rating and time consuming. Okay? So we have a 3 types: simple one, content one, and also collaborative filtering. So let's look at the content based first. Always remember what is content based? Based on the similar properties, similar features. Okay, look at the second recommended system. It's called content-based. Okay, okay. So in this content-based collaborations, we would like to build a recommended system to recommend a movie to the user. If the user, let's say, choose Toy Story, so what kind of movie that your system will recommend to this user? Okay. So this is the data set that we have here, obtained from the Kaggle. So we have an adult, whether it's an adult movies, what is the budget, what is the type of the movies, and a lot of attributes here. Overview is the synopsis, popularity. So among all these properties here, we will just look into this overview. Okay. So forget about all this popularity. So we will just focus at this overview, which is the synopsis. It means that this system should be able to identify the synopsis inside this Toy Story. If let's say the user select Toy Story, so we will do a scanning, see which movie their content is quite similar to the Toy Story, then we will recommend to the user. Okay? I repeat again. If the user chooses Toy Story, your system should be able to capture this overview, what are the properties, then to scan through all this movie to find which movie they are having quite similar overview compared to the Toy Story. Similar properties, no? Okay, but what is the nature or data type for this overview? Number? String. So how to extract the properties, features from a string? Back to NLP. Oh, sudah lupa. Anyone remembers how to extract the features from a string?
Separate the words first.
Tokenization is one of the process. It's not extract the features. Lemmatization is one of the pre-processing. It's not extract the features.
The word property.
Yeah.
Like the verb,
The
noun, the noun.
The word, the noun is another pre-processing. It's a passing. Cannot recall. Do you remember there's one function called cow vectorizer? Đọc đây nhỉ? Cow vectorizer?
Count the number, how many times
Yes.
it appear.
Yes. Count the frequency. How many times this word occurs? For example, you look at the Toy Story. So we have a movie one, Toy Story. So we will find out what is the word. Let's say we have this kind of term. It's called Woody, baby toy, happily, what else? I take some example. Birthday, and so on and so forth. So we will start to count. Okay, Toy Story, how many times will it occur? Maybe 2 times, 2 times, 1 times, 0, 2 times. Then we have other words. Then we have go through another movie, Jumanji. So we don't have movie here, we don't have toy, we don't have happy, we don't have birthday. Maybe second one is the board. Maybe we have a game here. So this is 0, 0, so this is 2. So remember in this table, now, to calculate the frequency of this term appears inside this movie. To calculate the frequency of this term appears inside this story. This is how we extract the picture from a string. Okay, so this process is called term frequency. We would like to calculate the frequency of each of these terms. This is called term of the frequency. Okay. Then what we do, remember how content works, similar properties. So we will start to do a comparison using some correlation or using a cosine similarity. Compare 2, 0, not similar, right? 2, 0, not similar. 1, 0, not similar. Not similar, not similar, not similar. Then from here we can say that Jumanji is not similar to Toy Story in terms of the pictures here. And we won't push this Jumanji to the user if the user chooses Toy Story. If we have another movie called Toy Story 6, so we start to calculate, let's say we have a 2, 0, 1, 0, 0. And in this case, we compare 2, 2, similar, about similar, not similar, about similar, okay. So then maybe we can say, oh, movie 3, they are quite similar. There are some other similarities between movie 1 and movie 3. Then we will push this Toy Story 3 to the user if the user select Toy Story. Why? Because the features are quite similar to the first one. Is that clear? Okay. Here. But my question is, what if let's say now you have another, let's say, term. For example, assume that I don't use stop words. We have this kind of words. Okay, is a common word, maybe it appears 20 times. If you have this case, then your calculation will become wrong. Why? Because you will see that Jumanji is 18 quite similar. Then Jumanji is quite similar to Toy Story. Toy Story also quite Toy Story 3 also quite similar to Jumanji, and same goes to this one. Then in this case, term frequency is not applicable. We cannot use term frequency to compare the terms. Okay, how? How to solve this? Huh? Remove the stop word, but somehow we have some words that is not stop word, but it appears everywhere. Maybe running. Running is not stop word. Maybe in this movie we have run, Jumanji you have a run, Toy Story you have run also. So how? So in order to solve this term frequency, the problem that I mentioned above, we have to apply DF, IDF. So this technique is not only applied for the recommended system. For those who are doing NLP, we probably heard about this term, and this term is very important. So this DF, IDF is a two process here, term frequency, this one, to calculate the frequency. IDF is another process to identify the significance of a word. How significant of a word. Okay, so explain a little bit the theory behind IDF. The IDF, the equation will be equal to the document okay, you can search the IDF for this equation, so you get this equation here. What does it mean? Okay, we take example. East. We take an example East. Okay. Can you tell me how many movies inside my database? 3. 1, 2, 3. So total document means that total movies are. Can you count how many documents with the word called is? How how many documents in this table come with the word is? 3. Can you use calculator, Google, log? You see log, you scared, I know. But a simple calculation, log 1, you get what?
0.
Very good. What does it mean by 0? It means that this word is not important. That's why it gives a value 0. It's a weight. So you use this weight multiply with this frequency, you get 0. And this value will turn to 0. All will turn to 0. It means that this word is not important. What if, let's say, you would like to compare a word called, let's say now you have 100 documents. 100 documents. You would like to calculate the IDF of toy, or the word toy. So log total document, let's say 100. How many documents come with the word called toy? In this table. 2. Only 2. Can you calculate what is the value of log 50? Log 50? Huh? Log 50? How many? You get 1.7. You get about 1.7. So this value shows that this point is very important, it's very significant. Then you will have this word about a value called 1.7. 2 power 1.7. 2 power 1.7. So by using this TF IDF, we are able to solve the problem that I mentioned where you have some words that appear everywhere. Okay? So we are going to eliminate the words that appear everywhere, although whether it's important or not important. Apply this TF IDF to eliminate that word. Okay? Yeah. So come back to here. So import the data set. Okay. So in this case, we are going to use this overview as our properties. Always remember, compare the similar properties in this recommended system. Generate the features, as I mentioned, I'm going to use TF-IDF. So you just call this function called TF-IDF vectorizer. So it will come up with this value, tabulate a table for you. Okay. So once we have this table, then we do a comparison. As I mentioned, we have this value here, then we do a comparison. Okay, compare these two documents. Okay, Toy Story. What is the similarity between Toy Story and Jumanji? Okay, based on these two values. After that, we calculate what is the similarity between this Jumanji and Toy Story 3. Then after that, we compare Toy Story 1 compared to the Toy Story 3. We will get some value. So this value is referred to the similarity. Okay, so you can use different technique to calculate the similarities. In this case, I'm going to use cosine similarity. Okay, so you don't need to worry about what is cosine similarity. Cosine similarity will give you a very high value near to 1 if they are similar. If they are not similar, it will give you a value 0. Okay, then you will get this table. So this table shows that what is the relationship? Okay, how similar movie 1 to the movie 1? Definitely 1 similar. What is the similarity between movie 1 and movie 2? So you get some value. What is the similarity between movie 1 and 3? 0. Means that they are not similar at all. Okay, and so on. So this is the table that we want to find out first. Okay, so that if in future, if the user select Toy Story, then we will just scan through this row to find out which value is the highest one. Okay, the highest one, it means that this movie is similar to the Toy Story. Okay, so yeah, so this is basically how it works. It will scan, it will go through this. Yeah, so this is the table that we would like to tabulate the similarities, similarity table. So when we have a similarity table, then we can search up. Let's say in this case, we would like to search what is the movie. Yeah, quite similar to the Toy Story overview. Then these are the movies. These are the movies that having similar properties to the Toy Story based on this value. Based on the value that tabulate. Okay. So I give you 5 minutes to go through. You run the code, try to understand. Any problem? This one.
Indian.
The one we don't have Okay, so for this one, get teacher's name. I think this is already out. You have to update these functions. So if you run this code, you will found there is a problem until this stage.
But the code after that can still run.
A moment. Okay. Which line?
Section 2, second code snippet.
Section 2, this one.
Yes, the second code.
Oh, okay, here.
That's the first one.
This one.
EFIDF dot get.
Okay, so you update to this one. You add underscore out. Okay, so this is the latest function, so you just substitute inside here. Okay, you add underscore out, then you should be able to run this code. Okay?
Okay.
Can
Okay.
Yeah. Then you get the matrix. So from the matrix, then you are able to plot command of product.
Okay. Mali. Wow. Có đọc vấn đề luôn.
No, this is the new one, yeah, the new one. Is this really recommended for Toy Story? I searched in Google, what the hell is this?
Wait, cannot run?
Based on the overview,
It's
that's why
not
you
defined
want to verify
the-
how accurate is it and improve it. Maybe the features are used is not very accurate. Maybe you search on that answer. To me, that means not inside here, so try to search the correct response here.
Hả? Dạ, tao ơi. Sợ. Dạ, tao ơi, sợ kiểu.
Why? Is it just... Oh.
Mali. À, tay tối.
Did you run the previous code?
就是把
You run all this? Not anything. Can run up to one place.
嗯，可以。你要从头跑一下的空。来的，来的，no problem.
Really, find it out.
I tried something earlier, I can't see.
Yeah.
Maybe it's a semester?
Maybe. If you don't want to use this so complicated technique, remember previous chapters we learned about unsupervised machine learning. You can use unsupervised machine learning to find the similarities. Remember what is the purpose for unsupervised? To find the similarities. So you use unsupervised, so you try to find the similarities between this and this, group them together. So whoever find the Toy Story, so we will found this Toy Story similar to this figure. Okay, you can use unsupervised machine learning. Not necessarily technique that I show in the practical.
Yeah, maybe because the here we only take until 5 minutes.
哦，没写
这样这样子就好。
我觉得我会拿题，
Already
直接来个洗给你。
老师，yes，老师我好像 recommend student do like this can get air。
good, but you won't go to C 啦。
哦，
明明。
那这样我比像我这样做。
Don't do then F 啦。
玩笑。
You can go to the collaborative here. So this part 3 is actually exactly what I explained to you earlier on. The purpose for collaborative is to build this table. User item. If you don't have this table, then you cannot build that collaborative filtering of recommender system. So if you look at the first section here, it's basically just to import the data. Okay. So we have two different files here. We have a so-called movie ID title. It's to show the ID as well as the title here. And also we have another data set which is called file.tsv. So you can run with the open with the notepad. Okay. So you have two different files. One is the ID title. And then another file will be another file is the data set. So this is referred to this 5 means that movie number 5, Shanghai Tribes. Okay, and this is not mistaken. What's the meaning? Let me double check this. Okay, so okay. So this is the rating. So this is the rating. So this one is the movie ID. We have to refer to here 1960. This is movie ID 50. Movie ID 50. Let's say in this case, Star Wars. Okay, means that this is the first user ID, index 0. He read the movie ID 50, which is Star Wars F5. And then second user, same user, index 0, read 172 movies, which is this Empire Strikes Back, and he give rating 5. So we have two different files here. We have to merge them together first. So in this case, I'm going to use a function called pd.merge. So if you use this merge, then it means that you will combine based on the similar IDs, you will combine the files together. So why do we need to combine the files together? Remember, we need two informations in collaborative. The first one is the user ID. The second one is the product rating. So we have the user IDs, we have a product rating, so that we can build. So all these are data exploration. That is not very important. Okay, is to build this table. Our end objective is to build this table. So we just use this function called keyboard_table. So if you call these functions, then you insert these two information. We need user ID against rating. User IDs against rating, then it will build this table for you. Okay? So this table is very important to cluster the similar item together, like in this case. Okay? So, but you will see a lot of NAN, it means that not available, so you don't have such rating for the particular movies. And also this is the main limitations in collaborative filtering of recommender system. We don't have the rating. Okay, but however, it's not showing all the movies. Maybe some movies you have a rating. So once we have this table, then we can actually recommend, let's say in this case, Star Wars. Okay, Star Wars. So,
A different one.
So our table is different.
different in terms of
Yeah, multi-purpose.
And we don't have user ID. Yeah. Why?
Okay, so we have this table. Let's say you have a user ID 1, 2, 3, 4. Then you have a movie, Star Wars. Okay, you have a movie A, movie B, and movie C. Let's say lah. And then movie 1 rate 5 here, rate 5 here. And then user 3 rate 5, 5, 5, 5, 5, like this. So once you have this table, then we can actually find the correlations. So we use a function called correlation here, correlation Star Wars. So if you identify what is the relationship, what is the similarities between these two movies, this Star Wars and also the A. So let's say this is 1, this is 2, then obviously this is not similar. Then Star Wars is not equal to A. Then we try to compare. Star Wars compared to B using this correlation function. So they are quite similar. They are quite similar, then we know that Star Wars is actually quite similar to movie B. So whoever go and search Star Wars, we will recommend movie B to that user group because they are having quite similar rating. Whoever likes Star Wars, then he will like B also. Okay? I'm not going to explain the syntax or the functions line by line up. I think this one you can search the Google. But the most important thing is the AI application is the concept, is the idea. If you don't understand, you got the syntax also no use. Okay? Yeah. So I hope for those who are doing a recommended system, it's able to help you lah. For those who are not doing recommended system, you know lah. So just additional info for you. How to build a simple recommended system. We need this information, rating, and also the user ID. Okay? So we still have time, you go through. So if you have any question regarding to your assignment, regarding to this, yeah, please let me know.
格局不够200。
So I would say recommended system is compare among the all the easiest one. The code is that as long as you get a data set, you just follow the code. Then elephant.
How to get additional features?
How to get A is depends on how you analyze your result, or how to let's say in this case you can use different type of correlation. So how do we compare the similarities between this and this, between this and this? You have various techniques. You can use cosine similarities, you can use correlations, you can use unsupervised. So I want to see how you understand and how you apply the techniques and to compare the result. Yeah. Well, the one I show you is just cosine similarity. There are a lot of techniques to compare. Then you compare. And then maybe in this case you build your own UI. Wow. UI. Let's say you assume the user key input Star Wars, or maybe food recommended system. You key in sushi. Then your recommended system should be able to recommend the food that's similar to sushi. Maybe at the same time provide the link or provide the locations. So you just try to think or build an assignment that's quite close to the daily life. Then that's going to add point like marks. Yes.
你看到东西了，你现在看到人你就显示这个是西米，这个可以家里装，不给我，这个经常出现在去哪里抓？
So we will know enough or not when we get the accuracy. That's only we know enough.
So we just go ahead and use it.
You use it until you get the result. Then if the result is not that high, not that good, maybe one of the reasons may be a number of errors or not decision. We are not sure.
So we are not sure what.
This review is what regarded like let's say you are using what my week to review. We have some price and other price. Can do a comparison.
For example,
What you can compare it because one they go out and they graduate from here, so you do something. The most important are the one you should you have to justify to it. Why? Because among all I subscribe that this is those things I want to train you first. I don't find several types of experiments and do a comparison and justify the one you want. Maybe you can use manual way. How you train your you're using a manual calculator. How you do it? Definitely you can send me to measure but have to come back to one negative. Maybe manual way. The one is a manual way.
Thank you.